In this tutorial, we're going to take a look at applications of the normal distribution. And on the first page, we're going to take a look at the normal curve and the percentages of the population that are between certain standard deviations. Mu stands for the mean, so that's the middle of the normal distribution. And so mu minus sigma means that's one standard deviation below the mean. Mu plus sigma, that's one standard deviation above. And these two bars, basically, they contain 34% of the population. Now 34 and 34 is 68, so basically a normal curve has 68% of the population between one standard deviation below and one standard deviation above. So this is the middle 68% of the data. Now we want to calculate the amount in the next two bars, from one standard deviation to two, one standard deviation above to two standard deviations above. Then what we can do is this. Now we're told that that's the 68%. There's actually 95.5% between two below and two above. So if we subtract 95.5 and 68, we'll get the percentage that's in these two combined, and then we divide that by 2 to get how big each one is. So that's why I'm subtracting 95.5 minus 68 divided by 2. So basically each of those is, well, just under 14%, about 13.75%. To find the percentage in the next two intervals, we would take 99.9 and subtract 95.5, 99.7, sorry, minus 95.5 divided by 2, which is 2.1. So if we didn't divide by 2, we'd actually get 4.2. So there's 4.2 and here combined. We divide it by 2, and each one of these is 2.1%. Now, the percentage of the population that's either below 3 below the mean or above 3 above the mean, we would take 100% and subtract the 99.7 and divide by 2, so there's very little. This is 0.15%, and so would this be. And so that's in the extremely unlikely category. This is still less likely, and of course this is most likely, so you can kind of categorize it like that. Now notice if you add up all these probabilities, and that's what I've done up here. So the 0.15, there's two of those, so times 2, 2.1 times 2 plus 13.75 times 2 plus 34 times 2, you get exactly 100%, and that's true of any probability distribution. All the probabilities should always add up to 100%. So a few examples on this page and the next couple. The lifespan of a particular species of sea turtle is normally distributed with a mean of 170 years and a standard deviation of 35 years. And we're asked in A, what is the probability a randomly chosen turtle will live for less than 140 years? There's only really three kinds of different probability calculations here. There's the less than that we're going to do here, and then there's between two different ages, and then above one. So we're going to do one of each here, basically. So in A here, so less than 140 years, so we have to find the z-score of 140 years. And so that's why we're told the mean, so that's 170, and the standard deviation is 35. So we'll make that substitution. And so 140 minus 170 is negative 30, divided by 35 is negative 0.86. And so we want the probability that's less than this. So we want the probability that z is less than negative 0.86. And so we read that from the table. Negative 0.8 is here. So we're going to go across to the 0.06 column. So we'll come down here. And so negative 0.86 is this number right here, the 0.1949 number. So the table actually gives you the less than probabilities. So that's why that probability would be 0.1949, or about 19.5%. 19.5% of the turtles will live less than 140 years. In B, we're asked, what's the probability a randomly chosen turtle will live more than 220? So we're going to do the more than here, and the last page we'll do the between. So more than 220, we need to find the z-score of 220. So we put 220 here, minus the mean of 170, and the standard deviation divided by 35. And so this is 50 divided by 35 is 1.43. So it's 1.43 standard deviations above the mean. So we have to look up 1.43 in the z-score table. So 1.4 comes across here, and down the 0.03 column, so we're looking at 0.9236. Now remember, the z-score table gives you the probability of less than 1.43. We want the probability it's greater than. So basically 92.36% of the population is less than 1.43 standard deviations above the mean. Since we want greater than, that's why we're subtracting this from 1. That's why it's 1 minus this 0.9236 number, which works out to be 0.0764 or about 7.6%. And on to the last example in C. What is the probability that a randomly chosen turtle will live between 110 and 250 years? So we did the less than probability question and the greater than. Now we're doing between two particular ages, the 110 and 250. So we need to find the z-score of both 110 and 250. So here's the 110 calculation. Same mean and standard deviation, of course, as in A and B. And then we need to do the 250 as well. So 250 goes in place of x minus the mean of 170 divided by the standard deviation of 35, gives us a z-score of 2.29. Now, this is what it looks like in a normal curve. Here's the negative 1.71, and here's the 2.29. So we want the probability that a randomly chosen turtle is between these years, so it's the same as it's between these two z-scores, because this z-score calculation basically transformed this, so we can use the particular mean and standard deviation we have. So between 110 and 250 is the same as between negative 1.71 standard deviations or below and 2.29 above. Now, so basically what it looks like is this. We're looking for this whole area between the two of these. And so to calculate this, we need to calculate or find the probability z is less than 2.29 and subtract from it the probability z is less than negative 1.71. See, when we do actually I'll put the numbers out here. If you look in the z-score table, that's for a z-score of 2.29 we get 0.9890, and for the negative 1.71 we get 0.0436. So remember, this 0.989 means that's the probability of a value has below 2.29, which is everything here. We don't want to include this. That's why we're going to subtract the 0.0436. See, this actually has an area of 0.0436. We don't want to include that because we're just between the negative 1.71 and the 2.29. So that's why we subtract them. And so we get 0.9454. So about 94.5% of the turtles will live between 110 and 250 years, which certainly is most of them by far. And that's the end of the tutorial.